and we talked about convolutional neural networks. And we finished the subject of deep learning in the previous session. Okay, we said that the convolution neural network is a neural network that has two parts, the feature extraction and the classification. The feature extraction is used to extract some features from the data, and then we have the classification. In the feature extraction, we had the convolution layer and the pooling layer, and in the classification, we had some normal layers for in the neural network. Okay. Okay, I put a slide. I put a video about the KNN. Did you see that video? Okay. Do you have any questions about that video? Okay, I will review the KNN classifier that we had a video about it. I will review it. Okay, we said that the KNN classifier, it is a classifier which doesn't have a learning model. Okay, this is very important. In the KNN classifier, we don't have a learning model, so we don't have any training. In this type of classifier, we don't have a training phase. We don't have any training. And the algorithm of KNN is like this. Assalamu alaikum. In the training phase, we don't do anything. We don't have training, and all the tasks are done in the test phase. All the tasks are done in the test phase. Okay. In the test phase, for every test data, we calculate the distance with all the training data, and then we get the k nearest data to the test data. And then after this, we select the class that has the majority in the neighbors. Okay, so in the KNN classifier, the classification is based on the neighbors of the test data. Okay, we find the neighbors, we find the nearest neighbors, and based on those neighbors and the class and the label of those neighbors, we do the classification. Okay, that's what we do in the KNN classifier. Okay, in this figure you can see an example of the KNN. You see that we have two classes. Some of the data are black and some of the data are yellow. Okay, some of the data are black and some of yellow. So we have two classes. And then this data, this is the test data. Okay, this is the test data, and k is equal to 3. Okay, we find these are the neighbors. These are the free neighbors. 1, 2, 3. And in these neighbors, we see that the yellow label, the yellow class has the majority. So we say that for this data, our prediction is yellow. Okay, do you understand this? So this is the KNN classifier. It is classifying the data based on the neighbors of the test data, and it's very simple. It's very simple, but it is time consuming. Okay? It's time consuming. When the size of the training data is big, okay, we have to find the distance to all of the training data, and that will be time consuming. And then we have to sort it and find the nearest neighbors. Okay, finding the nearest neighbors means first you have to calculate the distance with all of the training data, and then we should sort it, and then we can find the k nearest data. So it's time consuming. The test phase is time consuming. Why k is equal to 3? This is not k could be anything. K could be anything. Okay, it's a parameter. We could set any value for k, but usually k is an odd number. Okay, k is an odd number. 3, 5, 7, 9. Okay, because we want to find the majority, usually k is an odd number. Okay, and I said in the video that the KNN we could use different distance metrics in KNN. Euclidean distance, Manhattan distance, and cosine distance, and other distances. These are the formulas of these distances, and these distances are different. For example, the Euclidean distance, it finds the direct distance between 2 points, but the Manhattan distance finds this. It's different. Okay, these distances have sometimes have different results. Okay, so this is the KNN classifier. Is very simple. It is time consuming. It is multi-class. Multi-class means that it could classify uh, data with multiple classes. It could classify data with multiple classes. Okay? It means, for example, uh, if we have some uh, if we have some data in the fruit classification, and the fruit classification it has um, mm, it has 10 classes, for example. Okay, 10 classes. 10 classes is multi-class. Okay, 10 classes. If the minimum number of classes is 2, the minimum number of classes is 2. Higher than that is multi-class. Higher than that is multi-class. Okay, so higher than 2 classes is multi-class. Yes, k could be any number. K could be any number. We can select k by trial and test. We can select k by trial and test. Trial and error, sorry. Yes, as I said, these are the disadvantages of k and n. We should set the k value. The test phase is time consuming. This is a disadvantage of k and n. And the memory consumption is high. These are some disadvantages of k and n. Okay, so k and n is a very simple classifier that doesn't have a learning, and it is doing the classification based on the neighbors. Okay? Okay. If you have any question about the k and n, please ask. Okay, did you see the exercise? The second exercise, did you see it? Yes, about the pre-trained. Okay, do you have any question? Do you have any questions about it? No problem. Okay, you have to do a little search about that topic and the put the result of your search in a document in a report. Okay, and about two or three pages, 3 pages. Okay, so yeah. Okay, and about the exam, midterm exam, it is after 2 weeks. Midterm exam. Yes, uh, if you want, you can explain more. Okay, more than 3 pages, but not more than 5 pages. Okay, I don't want very uh, too much explanation. Okay, a very try to summarize your explanation and give a short explanation. Okay, about the exam. Okay, we will have some multiple choice question. Okay, I said that the slides that will be in the midterm exam. I said the first two slides. Yes, the slide about classification and the slide about neural network. Okay, and we will have some multiple choice questions, and we will have one question that you have to write a solution for it. Okay, you have one of the questions you have to write a solution for it. Okay, yes, homework two, yes, 3 or 4 pages. Okay. PDF, all of the reports PDF. Okay, uh, 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 in the midterm exam, some of the questions are uh, multiple choice. Okay, so you have to read the slide, the first two slides, and we will have uh, one question that you have to solve it. Okay, uh, and that question would be about neural network, about the perceptron. Okay, if we had an algorithm about the perceptron. Okay, we had an algorithm about the perceptron, and I talked about it in the online session. I talked about the algorithm, and I gave you an example about it. Yes, do you remember? Okay. Okay, we will have one question about the perceptron, and that we talked about it in class. Okay, and the rest of the question will be multiple choice. Time of exam is after 2 weeks. Okay, after 2 weeks, and after 2 weeks, and the time is the time is 12:40. 12:40. Okay. The time of the exam is 12:40 in 2 weeks. Okay. So at that time you should enter. Okay. Let me show you the web. Let me show you the link. Okay. You know this is the link. Yeah. This is the link here. Okay. Yeah, you have to enter this link at this time. Okay. The first two slides. The first two slides. Slide 1 and 2 about classification and neural network. Okay. The number of hours, no, it's not very, the time is not very, sorry, I'm sorry. The time, the exam will start at 12 o'clock. Okay. The start, the exam will start at 12 o'clock. Okay. I'm sorry. The time of the exam is about 40 minutes. 30, okay, 40 minutes. Okay, so the exam will start at 12 o'clock after 2 weeks, and your time is about 40 minutes. Okay, for the question that you have to write a solution. Okay, the some of the question are multiple choice. Okay, no problem. You have to just select the right answer. Okay, and for the question that you have to write an answer for it, you have to take a picture with your mobile. Okay, you can write it on a paper and take a picture with your mobile and send it. No, it is in Darsa, not Osmon. No, in Darsa. Don't worry about the time. It's enough. Your time is enough. Don't worry. No. The question I said about the neural network is not the same as the exercise. In the exercise, you are writing a program. You don't want to write a program in the exam. Okay. Okay. You have to. I give you a question and you have to write the answer. Okay. If you check the neural network session, I have give you an example in that session. Okay, it's similar to that example. Okay, take a look at that session. And do we have class in next week? Next week, do we have class? I think we have class in next week. Yes, we have a class in next week. We will talk. We could talk about it in next week too. Okay, take a look at the online session about the neural network and the perceptron. I have an example there. I have talked about an example. It's similar to that example. Okay. 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 The next subject that we will talk about is decision tree. Okay, decision tree is the next subject that I will talk about. I have put a video about decision tree in the Darsa. Did you see that video? I put it in Darsa. I think two days ago I put it. Okay. Uh, I said in data, we have some data that are nominal. Okay, what do we mean by nominal data or nominal features? It means data that the features have string values. The features in the data have string values. Okay, so nominal features means features that have string values. For example, the color the color feature, the values for the color feature, it could be the red, green, and yellow. Okay, these are string values. Okay, these are string values. So we call this feature nominal feature. Now, how could we classify these this type of data? How could we classify it? Uh, in this type of data, we can't use the classifiers which work with numbers. Okay, we can't use the classifiers which work with numbers. So how could we classify this type of data? Okay, the solution is that if we have a classifier that could classify data based on some questions about the feature values. Okay, this could do the job for us. Okay, for example, in fruit classification, the features are color, size, shape, and taste. Color, size, shape, taste. And so all of these features are nominal features. Okay, and we want to classify the fruit. How do we do this? Okay, we do it like this. We say, what is the color? And our answer is green. And then we say, what is the size? Our answer is big. Okay, these answers are based on the test data. Okay, so we have in the test phase, we want to classify a data, a fruit. Okay, we do the classification based on some questions. What is the color? What is the size? And based on these questions, we do the classification. Do you understand? Uh, the question, Mrs. or Mr. The question is based on the features. Okay, in the data, what are the features, and based on we ask about those features. Okay, we ask about those features, and the values here, because the features are nominal. Okay, nominal means the values of the feature are character or strings. Okay, and the uh, each feature has a limited number of values. Each feature has a limited number of values. Okay, so each feature has a limited number of values. Okay. And in our example, we asked two questions. What is the color? The answer was green, based on the test data. Okay. And what is the size? The answer was big. And then the classifier said the fruit is watermelon. The fruit is watermelon. Okay. This was the result of the classification. Okay. Now, so we want to build the classifier that asks some questions for the classification. Okay, we could do this using this tree. Okay, look at this tree. Here in the root node, we have the color feature. A question about the color. What is the color? Okay, do you see the question? Okay, Mr. Asif. Mr. Asif, Ali Asif. You said that does the feature have more than one value? Yeah. You want to ask your question, okay? Do you have microphone? Do you have microphone? You can ask your question.
You have my voice?
Hello, yes, yes.
Thank you. Doctor, the one feature, could we have more than one value?
Yes, yes. The values of the feature for the color has three values: green, yellow, red. Yes, okay. It has more than one value. Is that your question?
It is options, but we have to choose one value. Or
Yes,
we
yes,
can.
yes. Because you know, as I said, okay, we want to do a classification. Okay, classification means we have a data. Okay, we have a data like this. Okay, let me. Okay, okay. Thanks. I understand your question. I will explain about it. Okay. Okay, we have a data. Okay, we have a test data like this. Okay, uh, red, medium, red, small, and sour, and round. Okay, this is our test data. Okay, we have a test data. You remember that in the classification we have two phases. The first phase is the training phase. Okay. In the training phase for the decision tree, in the training, okay, we have built this tree using the training data. Okay, we will talk about this later in the next slides. Okay, we have built this tree using the training data. And then this is a test data. We have a test data, and in the test data, we have a fruit. The color is red. The size is small. The taste is sour, and the shape is round. Do you understand this? This is a data that we want to classify it. Okay, now we give this data to the tree. We give this data to the tree. Okay, we give this data to the tree. What happens? The tree says, what is the color? And our answer is red based on the data. And then it says, what? Okay, it says, what is the color? We say red. So it comes here. Then it says, what is the size? We say a small. So it comes here. Then it says, what is the taste? We say it's sour. Okay? So the answer is what? Grape. Grape. Okay? In this tree, the classification comes to here. Grape. It says this fruit is grape. Okay? Do you understand? So we have built the tree using the training data, and then this is the test data. We want to classify this test data. We want to classify this test data, okay? And we give this test data to the tree, and the tree asks some questions about the features, the color, the size, okay? And then it does the classification. Okay? I said that we have some data, okay? In data mining, we have some data. Some of the data is training data, and some of the data is test data, training and test data. And we are using the training data for building the tree, and we use the test data for evaluating the tree to see how accurate is the tree, okay? What about, okay, Mr. Asif asked a question, what about the shape? Shape, okay. You know, here we didn't have any question about the shape because in the tree we didn't have it. Okay, the questions depend on the tree. The question depend on the tree. If the color of the fruit is yellow, okay, then we have a question about the shape. The first, okay. The question is about the shape, okay? This depends on the tree. I will talk about this, how do we build this tree, okay? This is the main subject in this slide. It is how do we build this tree. Okay? We build the tree using the training data. We build the tree using the training data. And then when we have built the tree, we do the classification. When we have built the tree, we do the classification. Okay. In this slide, it says that in the decision tree, these nodes, the nodes that are not the final node, okay, we call these nodes the internal nodes. The internal nodes, they have some features in them, okay. The internal nodes, they have some features. The branches of each node, it is the feature values. For example, the color is green, yellow, or red. These are the feature values. So in the branches of the tree, we have the feature values. And then in the leaves of the tree, we have the classes of data. Okay. So in this tree, we have some leaves. The leaves are the classes. The other nodes, they have some features. And the branches are the colors. The leaves are the prediction, okay? The prediction. The final prediction. Okay, as I said, in this decision tree classifier, the learning model is a tree. Okay, the learning model is a tree. So we want to build a tree using the training data. As I said, in this tree, when we want to classify, it's like that we ask some questions. So the main point is, how do we build this tree? How do we build it? Okay. One important point about the decision tree is that the decision tree is dividing the data into subgroups. Okay, what does this mean? Okay, when we are building this decision tree, okay, for example, in the root node, we say that color is the root node in the tree. And then we say that the color, it has three values: green, yellow, and red. Okay, so this is the first step in building the tree. We select a root node, okay, and then we put the branches, the values. Okay, now I will talk about it. How do we select? How do we select a feature to put it in the notes? I will talk about it in the next slides. Okay, I will talk about it in the next slides. How do we select a feature to put it in the notes? Okay, when we have selected the feature and we put it in the node, in the root node, okay, this feature, it has three values: green, yellow, and red. Okay, when we in this branch, I mean the green value. Okay, when we come here to this node and we want to select which feature to put it in this node, okay, the data that we have in this point is the data that the color is green. Okay, so when we come into this branch, our data is limited. we don't work with all of the data. We only work with the data that the color feature is green. Okay, when we come here, we work with the data which the color is yellow. And when we come here, we work with the data which the color is red. So we are dividing the training data when we are building the tree. Okay, do you understand? Okay, you will understand this in the next slides. Okay, because when we are building the tree, we are using our training data to build the tree. Okay, as I said, in every classifier, we use the training data to build a classifier. Here, in this classifier, we have a decision tree and we want to build it, and we are using the training data. Okay, in the root node, we are using all of the training data. Okay, we don't have any limitations in the root node, but in the next nodes, okay, when we come down into the tree, in the next nodes, the data is limited based on the branches. As I said, here in this point, we are only working with the data which the color is green. Okay, so the data we are working with a subgroup of the data. That's what I mean in this point. This is a feature of the decision tree classifier, that when it is building the tree, it is working with a group, a subgroup of the data. I will talk about it, okay? In these slides, I'm just giving you a general view about the decision tree. Okay, we will talk about the algorithm and how this tree is built in the next slides. Okay, I'm just in these slides. I'm giving you a general picture about the decision tree and the features of the decision tree. I will talk about the algorithm in the next slides. Okay, so let's go to the main subject about the decision tree. Okay, we have many decision trees. Okay, we have many decision trees, and here I want to talk about the ID tree. ID tree is a decision tree. We will talk about it here. Okay. So the rest of our subject here is in this slide is about the ID tree, decision tree. Okay. The first point is, how do we build the tree? The first point is, how do we build the tree? Okay. When we want to build the tree, the most important thing is, how do we select the features to put in the nodes of the tree. Okay, when we want to build the tree, the most important thing is, how do we select the best feature to put into the nodes. Okay. In ID3, there is a concept, information gain. Information gain is is a metric for selecting the best features. Okay, so we select the best features using the information gain. Okay, so ID3 in ID3 we select the best features using something called information gain. Now, what is information gain? Information gain is based on entropy. Information gain is based on entropy. And entropy, it has a formula like this. Entropy, it has a formula like this. If we have a data and the data is represented by S. S is our data, okay? The entropy of S is calculated using this formula, the summation of I from 1 to C. C is the number of classes we have in the data, minus pi logarithm pi. Pi is the probability of class number I. For example, if we have two classes in our data, the entropy would be like this, minus p positive, probability of positive class, logarithm positive, probability of positive, minus probability of negative class, logarithm probability of negative class. Okay, so using this formula, we could calculate the entropy of the data. Okay, so this is the formula of entropy. Okay, let's look at an example about entropy. Okay, we want to calculate entropy on this data in this slide. Okay, C means the number of classes. Okay, two classes, three classes. It depends on the data, how many classes we have in the data. Okay, in this data we have eight. Uh, we have eight data. Okay, the data is about the tennis sport. Okay, this is this column is the output of the data. Play tennis. It means a tennis player. Some days he had played tennis, and some days he didn't play tennis. Okay, so we have two classes: no or yes, and the rest of the data is this: the outlook, the temperature, the humidity, and the wind. Okay, so based on this data, we have a data in the um, in our learning. Okay, using this data we want to calculate the entropy. Okay, you see that here we have two classes. Yes, in the decision tree, the classes are in the final nodes of the decision tree. Yes, that's right. You have my voice? Yes. So you see here that uh, our data has two classes, no and yes. No, yes. These are the two classes. And we want to calculate the entropy. We want to calculate the entropy of this data. Okay. So we say that the probability of positive means yes. Positive, positive means yes. Probability of positive. It means the probability of yes in the data. Okay, it's 6 divided by 8 because we have 8 data, and in this 8 data 6 of them are yes. So the probability of yes is 6 divided by 8 logarithm 6 divided by 8. And then the probability of negative is 2 divided by 8. The no uh, class. The no class. Okay. So entropy for this data is 0.24. Entropy is a value between 0 and 1. And it's better to have a 0 value. If the data has a 0 entropy, that's better for us. In this example, zero entropy means that all of the data have the same class. Okay? That's zero entropy. If all of the data is yes or all of the data is no in this data, okay? If all of the data is yes, okay, the probability of positive would be 8 divided by 8 logarithm 8 divided by 8. 8 divided by 8 is 1, okay? And the logarithm of 1 is 0. And then for the negative class, the probability of the negative class is 0. So the entropy would be 0. So if all of the data are in the same class, that's the best situation for the entropy. Okay, do you understand? So if all of these 8 data, all of them, the classes are yes, the entropy is 0. This is the best situation when this is the best value for entropy when entropy is 0. Okay, and the the worst situation is when uh, uh, half of the data, okay, when half of the data is no and half of the data is yes. That's the worst situation. In this situation, the entropy would be 1. Okay, if half of the data is yes and half of the data is no, the entropy would be 1. And this is the worst situation for entropy. Okay, so this is entropy. So we could calculate entropy on our data, and it has a formula, and we could calculate entropy. Okay, now uh, we said that in ID3 it select the feature based on information gain. This is the formula of information gain. Okay, information gain. Okay, we have a data S and we have an attribute A, and we want to calculate the information gain of attribute A in data S. Okay, this is the formula. As you see, information gain is based on entropy. Information gain is entropy S, entropy of the data, minus this is the entropy of the attribute. Okay, so uh, we calculate the entropy of the data, and then we calculate the entropy of the attribute, and the result is the gain of the attribute. Okay, so how do we calculate the information gain for an attribute? This is the formula. Let's have an example about it. Okay, we have this data. This is the data. Similar to the last example, it's about tennis. And we have 4 features: outlook, temperature, humidity, and wind. And this is the output: play tennis. Okay, we want to calculate the gain of the wind feature in this data. Okay, we want to calculate the gain of the wind feature in this data. Yes, information gain is the measure used by ID3 to select the best attribute. Yes, I said this in the previous slide. Okay, look at this example. We want to calculate the gain of feature wind. Okay, listen carefully to this example so you see how do we calculate the information gain. Okay, first we see that the wind feature, it has 2 values: weak and strong. Okay, so the wind value in our training data, okay, we look in the training data, we see that the wind feature has 2 values: weak and strong. Okay, so our data, S means the whole data. Okay, in our data we have 9 positives and 5 negatives, 14. Okay, 14 is all of the data. In all of the data we have 5 negative and 9 positive, 5 no and 9 yes. Okay, that's what we have in all of the data. Okay, now in the data where the feature wind is weak, in this data where the feature wind has the value weak, in this data we have 6 positives and 2 negatives. And in the data where the feature wind is strong, we have 3 positives and 3 negatives. Okay, no problem. Okay, so we, for the feature wind, it has 2 values, and for each value we said how many positive and negative classes for each value. Okay, now we want to calculate the gain of the feature wind. Okay, we want to calculate the gain of the feature wind. Yes, SS strong means uh, the the wind feature has the value strong. SS strong means the data. Okay, it means the data that in that data the value feature has the feature wind has the value strong. Okay, so we should check in the table to see in the data which the feature wind is strong, how many positives and negatives data do we have. Okay, so first we have to calculate this. We have to say in our data how many positive and negative. Okay, in this example we have 2 classes, positive, negative, and then we see in the data which the uh, feature is a specific value. For example, here weak, how many positives and negatives there, and also for strong, how many positives and negatives. Okay, then we calculate the gain of feature wind. Okay, we say that it is equal to entropy S minus the entropy of this feature. Okay, entropy S we have calculated before. This is the entropy of S. Minus 8 divided by 14 S weak. Okay, these 2 parts, I mean this one and this one, these are calculating the entropy of the data when the feature wind is weak. Okay, it means this data, the data which has 6 positives and 2 negatives. Also when the feature is strong, so it's 3 positives and 3 negatives. Okay, so we put it in the formula. 0.94 minus 18 divided by 14, 8 divided by 14, 0.8, and 6 divided by 14, 1. Multiply by 1. Okay, as I said, this part we are calculating the entropy on a specific attribute. Okay, and now when the wind feature has the value weak, okay, we said that uh, we have 6 positives and 2 negatives, so we have 8 data from all of the data, which are 14, that the feature wind is weak. So here we have put 8 divided by 14. And then 6 divided by 14 is the number of data which the feature wind is strong. It is 6 and all of the data is 14, so we said 6 divided by 14. Okay, this is the formula of the information gain. Okay, do you have any question about this? How to calculate information gain? Okay, so when we want to calculate the information gain for a feature, first we have to say how many data are in each class. This is very important. How many data in each class. In this example, we had 2 classes, positive and negative. We said that how many data are positive and negative for the feature value and for all of the data. The first one was for all of the data, and these were for the feature values. We said how many data is in each class. Okay, after we have set this and we have set this, we could calculate the gain, and the gain is equal to entropy of the data minus entropy of the attribute. Okay, and so the gain of the feature wind is equal to 0.04. 0.04. So the information gain is this value for the feature wind. Okay, and then we do the same thing for all of the features. So we calculate information gain for all of the features. Then we select the feature with the maximum information gain, and we put it in the node of the tree. Okay, so we calculate the information gain of all of the features, and we select the best feature with the highest information gain in the decision tree. Okay, the next subject is about building the decision tree. I will talk about it in the next sessions. Okay, so in this slide, we talked about the decision tree, and that the decision tree, in the decision tree, the learning model is a tree. So we want to build a tree. When we want to build a tree, we should calculate the information gain for each attribute. So we talked about um, how do we calculate this information gain, and then the feature which has the highest information gain, that is selected to for the tree, and we put it in a node in the tree. Okay, for the final exam, I will talk about it later, which part of this slide will come in the final exam. I will talk about it later, okay? Okay, thank you very much and have a good time. Goodbye. Yes, you could change your article, no problem. Delete the last one and add the new one. Okay. Okay, if you can't delete it, send me a message in Darsa. I will delete it for you. Okay? No problem. Okay, thank you and goodbye.